Support for today's episode comes from Amazon. Amazon is working toward a carbon free energy future, doing more with less, investing where it matters most, and supporting communities where we operate. 4 advanced nuclear reactors beat DOE's July 4th target. 4 DOE authorized advanced reactor experiments reached zero power criticality within 1 month, proving developers can compress construction and testing schedules under an accelerated federal pathway, though none is producing electricity yet. A May 23, 2025 executive order directed the U.S. Department of Energy, DOE, to establish a pilot pathway capable of bringing at least 3 advanced reactor designs to criticality by July 4, 2026, the nation's 250th birthday. 4 cleared that bar within a single month. Antares Nuclear's Mark 0 reached zero power criticality on June 4th at Idaho National Laboratory. Valar Atomic's Ward 250 followed on June 18th at Utah's San Rafael Energy Lab, becoming the first of the group to reach the milestone outside a national laboratory. Deployable Energy's Unity reactor reached criticality on June 30th at Idaho National Laboratory through DOE's Nuclear Energy Launchpad, a separate authorization track, satisfying the executive order's 3-reactor target. Allo Atomic's Critical Test Reactor completed the milestone on July 4th itself. DOE said the first 3 achievements made the United States the first country to bring 3 distinct advanced microreactor designs to criticality within a single month. Allo's test 4 days later raised the total to 4. None of the 4 is producing electricity yet. What criticality does and doesn't prove. All 4 were zero-power criticality demonstrations, run at extremely low heat levels rather than full operating power. They confirm that each fuel and core configuration can sustain a controlled chain reaction, and that the developer completed DOE's authorization and construction readiness process. They do not test commercial heat production, turbine performance, sustained electricity output, or economic performance. DOE has described the pilot program as a research and development exercise designed to compress the path toward the Nuclear Regulatory Commission's separate commercial licensing process, not to demonstrate commercial suitability directly. DOE authorization under this program does not substitute for NRC licensing at a normal commercial site, and none of the 4 reactors that reached criticality this month is supplying power to a grid or a customer. One developer is building its next reactor for a data center. Allo Atomics offers the clearest link between this month's milestones and corporate energy planning, though the connection is one step removed from what the July 4 test itself proved. The unit that reached criticality was a critical test reactor built to validate Allo's core design, not the power-producing unit itself. The company says it has separately begun work on a 10-megawatt electric integrated reactor intended to supply a co-located data center at Idaho National Laboratory and is targeting electricity production from that project in 2027. That date is a company target, not a validated commercial schedule, but it marks a shift from advanced nuclear as a multi-year hypothetical in corporate sustainability reporting toward a specific, dated project a facilities team could plausibly track. Most of DOE's original pilot cohort hasn't reached criticality yet. The 4 milestones do not mean DOE's full pilot portfolio has advanced at the same pace. The department's original reactor pilot program selected 11 projects from 10 companies, spanning different fuels, reactor types, sites, and authorization strategies. Oklo was the only company with 2 projects in that cohort. Most of those projects have not yet reached criticality. Oklo's Groves Isotope Test Reactor in Texas, a 15-megawatt thermal isotope production facility rather than a power plant, received DOE approval of its final safety analysis on July 1st and is targeting criticality later in July, capped at a maximum power level of 100 watts. It is not designed to supply electricity to a grid or a data center. Separately, Oklo's Aurora INL project, a 75-megawatt electric liquid metal-cooled fast reactor that broke ground in September 2025, received a preliminary safety analysis approval from DOE on June 11th, a distinct milestone from Groves, and not yet a criticality event. Deep Fission delivered a factory-built, non-nuclear prototype reactor canister to its Kansas borehole site this month, a step toward validating installation before any nuclear fuel is loaded. That spread illustrates how differently the original 11 selected projects have progressed since the program launched last August, even under an identical deadline and comparable federal support. Deployable energy, notably, was not part of that original cohort at all. It reached its milestone through the Nuclear Energy Launchpad, a separate authorization pathway DOE established in March 2026 to extend the same accelerated framework to projects beyond the initial group. Oklo's Aurora INL preliminary safety approval is a separate DOE authorization milestone from the isotope-focused Groves project, and it is worth tracking on its own terms. At 75 megawatts electric, Aurora INL is a genuine power-producing design, not a test or isotope facility, even though it remains well short of criticality itself. What this means for nuclear as a near-term planning assumption. These milestones provide early benchmarks for how quickly developers can fabricate fuel, construct zero-power facilities, and complete DOE authorization. They do not yet provide comparable schedules for commercial electricity delivery. The 4 projects use different sites, different regulatory pathways, and different reactor designs that are not directly comparable to one another. Firm, always-on power has become a central constraint in AI site planning, and this month's results move 4 technologies beyond paper design and into physical reactor testing. The next milestones: sustained heat production, electricity generation, NRC commercial licensing, repeat construction, and actual customer delivery, will determine whether that progress becomes relevant to real AI site schedules. A substantial gap remains between zero-power criticality and repeatable commercial operation, even for developers like ALO that are targeting electricity production as early as 2027. Sustainability Soundbites energy coverage is sponsored by Amazon. Visit the link in our show notes to learn more about Amazon's Spotlight on Energy. For sponsorship opportunities with Environment and Energy Leader, please reach out to a member of our team.